Without further ado, the main attraction, the Kawhi Leonard of data analytics, Tamer Salama. He's a senior tech professional with 15 plus years of experience in designing, implementing, and delivering diverse solutions, decision support, and information management systems in multiple industries. His most recent experience has focused on building solutions to further the use of data science and machine learning in addressing business challenges. I can dearly attest to the fact that he's very passionate about software and data engineering, solution delivery, and maintainability, and user engagement. Tamer holds a Master of Science in Information Systems from Northeastern University in Boston, and also a Master of Science in Advanced Mechanical Engineering from Imperial College London. Without further ado, Tamer Salama.
Hello, everyone. That's good. Thank you, Marc and Tim, for the invite. Thanks, everyone, for attending. That was awesome, by the way. I think it's the first meetup I attend where there is kind of a pretext workshop, which gets everyone thinking about data and analytics, which is great. Great idea. So, each one of us is carrying a computer in their pocket or purse or bag. So, and that thing that also makes some phone calls is chock full of software, applications, and solutions. Now, what I'm finding is that there is actually a separation between the use of those applications, or there's kind of, this gap is widening, the use of applications and the understanding of how applications are working. So, if we look at the lines of code in many of the applications, for example, Photoshop, when it came out, I think it was in the 80s or 90s, it was about 128 lines of code, 128,000 lines of code. Can anyone take a guess of the Ford F-150? How many lines of code are there? 150 million. So, software is eating the world, and it is in everything we interact with in modern days. If you're using any of those tools, you're most likely also writing software, either Excel formulas, VBA applications, Power BI, and so on. However, there is, as I mentioned, the gap of using the software and putting it together and how it is constructed and what it takes to construct that software. The gap is widening. So this is my humble attempt of demystifying of some of the challenges around putting software together, what the tools around putting the software are nowadays, and what the processes of what the challenge in the process of putting that software together is. And I'm hopeful that you can come out of something that you can implement in your own roles. This is not going to be a technical discussion. It's just going to be touching on many high-level components and processes. So, sorry, I forgot to maybe introduce myself, and Marc did, but if you need to get in touch with me, feel free to reach out on any of the social media stuff, Twitter, GitHub, or email me at synovus.com. So when we talk about software, what to cover? There is a lot to cover, basically, between languages, framework, techniques, tools. So it makes it a bit challenging of introducing the engineering of software to people. But what I decided on is split it out in three main parts: components, processes, and tools. So we're going to start with components first. So as you see, there are many applications that we use out there. There are common themes that are used in those applications. If we, for example, are interested in NBA, which, by the way, it's totally unscripted. I didn't know that Tim will be talking about NBA. But if you're researching about the Toronto Raptors, so you find a link on Google, and then you click that link. So what happens then? You're actually issuing a request or asking a server somewhere to provide you with data for the Toronto Raptors. So the request goes to the server, and the server communicates with its storage saying, well, this person is asking for Toronto Raptors information. Can you bring me back the Toronto Raptor article? So it brings back, it pulls back the article from the storage, wraps it in a bunch of HTML and JavaScript, and then serves it back to the user. This request response cycle is basically what is called as multi-tier architecture. And it's used in maybe 80 to 90% of all the software out there that you're using nowadays. So if you put this in your mind, you're gonna understand most of the how the applications are working. So N-tier or multi-tier architecture is an interface, which is your web browser or your phone, interacting with code, which is sitting on another machine, and that code is interacting with storage, which might be sitting on another machine. So if we break this down even further and talk about each of the components, we're going to talk about storage first. So storage is most likely is a database engine. And when we talk about database and database engines, there are different types of database engines. The most common type and the most mature one is a relational database engine. You can think of your relational database engine as glorified Excel sheets or Excel on steroids, where you can keep your data in a tabulated format with some associations between those data records. So for example, here we have a table called countries and another table called cities. And if you want to know what cities belong to each of the countries, you can just add a column of a country ID, which is called a foreign key that points to the record in the other table. So, and this is the most common type, and you can use it for multiple purposes. But if we talk now about vendors providing those type of relational storages, we have SQL Server from Microsoft, we have Oracle database from Oracle, PostgreSQL, PostgreSQL, which is an open source relational database, and MySQL, which is also an open source database. If you have an open source project, or if you have, a pet project that you would like to start, you can easily download PostgreSQL and install it on a machine and try playing with it. Or if you have a project on a budget, you can also do that. It's a very robust open source relational database. So what other types of database are out there? So we have NoSQL database. Came about maybe 10 years ago. But the notion here is that you're not storing your data in a relational format, you're storing it in a document format. So that document format you can think of as a key value pair or a key name pair. It is not stored in a table format, and it's easier in some aspects of being flexible. Like you don't have to design your tables up front or design your table structures up front. You can specify design them as you go. There are different vendors out there providing NoSQL. MongoDB, Cassandra, and Redis are the most common types, but there are many more. Another database type or database engine type is graph database engine. This stores the data in a node and edge format. So in this case, the same example, country and city, they are stored in nodes, and there are association or edges between those nodes. Graph database came about to solve the problem of a friend of a friend. So if you would like to know what cities that belong to a country that also are sisters of cities, you can issue one query against that database and bring back those records. They became popular, those type of databases, they became popular when the social media revolution came about, so maybe 10 years ago or so. Most common types are Neo4j, which is kind of the de facto standard now. There are some other types. Now, big data. So this is not truly a database engine, but it is another mechanism of storing data. So if you have a data that is generated from IoT devices or your phone or your watch, those type of data tend to be large in number and velocity. The volume of the data as well as the speed of generating this data is quite large. So in that case, you can store them in a big data platform. They are stored in kind of a raw file-based format, but there are abstraction layers on top that allows you to actually query this data. So instead of you actually storing the data in database tables, defining the association, there are other mechanisms. You can store data, just dump the file there, and then provide some layers that you can start interrogating the data. So give me all the measurements, for example, in this example, give me the measurements that are between this time and that time for that specific tag, and that database engine would respond nicely. And there are different vendors out there that provide that big data big data platforms. Sorry. Search engines, they are not really a storage mechanism. They are more of an indexing mechanism. But they are used in many websites. So if you're interacting with Stack Overflow, Netflix, or LinkedIn, or other websites, you're actually, instead of you searching the data or the databases, you're actually searching the search index. Google is a famous one as well. So the data there is stored in an index format or reverse index format. So each word would be known where it resides. And when you're actually giving it the word, it is searching the index, not the storage of this data, and brings back the results. And there are famous open source and other tools out there that you can actually use or leverage in your project. So ElasticSearch is the most famous, and it's becoming more popular now. Lucene is one, Solar is other, and Coveo is a proprietary one. So which database engine should I use in my project? I would say go with a relational database engine. Postgres is the most common one. You don't need to worry about NoSQL or graph databases. Start with a relational database and see if your project grows and you can start leveraging other mechanisms. Elasticsearch is another one, but this is a secondary storage. It's not a main storage. The data needs to be stored in a relational database, and then you can use Elasticsearch as some sort of an indexer of the data that resides in the relational database. Okay, so we're done with the first part, which is storage. Actually, it might be a good break here if you have a question, or we can continue on. So the other part is the code. So we're going to cover languages, libraries, and frameworks. We're not going to delve deep there, but it's just a high-level overview of each of them. So languages. So there are many languages out there, and some of them are specific, or they perform a specific function, like SQL, for example. Use SQL to interact with database and only to interact with the database. HTML it's a markup language. It's not truly a language, but it's a markup language. So you write websites or web interfaces through HTML, and it cannot do anything else. But for some other languages, like Java, for example, Python, this is a multi-purpose language. You can use this to write your web applications or interact with a database, write your analytical script. So it has lots of things that provide you with kind of a larger tool set. Here are some examples of some of the codes. For example, Python. This is a hello world that writes 3 lines of code that says hello world 1 or 0, 1, 2. 0, 1, 2. Hello world 0, 1, 2. So this is the same code written in R. And this is the same code written in Ruby. So you see that once you learn one language, it's easier to pivot to another. And it's just a matter of learning the syntax. Actually, I have a confession here that I usually look up the for loops before writing the for loop because it's easy to forget the format or the syntax of a language. So Stack Overflow is very helpful there. So libraries. So libraries are kind of another layer on top of the language. So they provide you with functionality that come prepackaged. Instead of you writing lower level code, you tend to leverage or include some libraries in your code that does a specific function and does it well. So for example here, PyODBC is a Python library that allows you to interact or open connections to a database. So instead of you writing low-level protocol code that basically knows how to communicate with a SQL server or communicate with an Oracle server, you can just include a PyODBC, and then using that PyODBC library, you can interact with many databases. So it provides that nice level of interaction that does one specific thing. Pandas is another common Python-based database interaction layer. It allows you to store data in memory and play with the data, provide some abstractions to aggregate and summarize the data in memory. And Beautiful Soup is another one that allows you to scrape remote websites. So if you want to interact with remote HTML-based websites, you can just include Beautiful Soup and through its API, communicate with a remote website, brings back the data and play with it. Then there is also frameworks. Frameworks provide yet another abstraction layer in your code. It allows you to do more than just one specific thing. It allows you to, for example, here, it allows you to build a web application, for example. So if you comply with a certain structure within your project, as well as include the framework libraries within that project, you can write web applications that stores data, provide some interaction with users, provide them with charting capabilities. So it's much more than just writing specific thing that can maybe analyze a data set. My favorite here is Rails, which is a Ruby-based framework. And it came about, I think, in 2003. But this application framework makes it very easy to interact with a database, brings back data records, display it on a web page for users, store user data, provide some authentication mechanism, and so on. Django is another Python-based one, and Flask is yet another Python-based one. So each of those capabilities are important if you want to productize or make your scripts or data analytics scripts more operational, provided for more general audience. A bit about open source here. I'm a great proponent of open source. This is usually my go-to place whenever I need to find something to work with, whenever I need to find a library or explore how to interact with a specific data set that may be very proprietary. This is my usually go-to place. So open source, I research open source tools that can do X and Y. And then voila, there are multitudes of projects. However, a word of caution here that each open source project comes with its own license. So it's a misconception here to think of open source as just free things that we can use. Actually, those free things come with our licenses, so you have to comply with those licenses. So if you're sharing if you've made modifications, for example, to one of the open source libraries, there are some licenses that actually forces you to commit those changes back to the library. So just be cautious of what licenses are available there. Open source initiative is a very good way to start to understand what the difference is between the licenses, and if your organization need to adopt one of them, you can actually reference the open source initiative and see what the pros and cons for each of the licenses. So generally speaking, what do you need to start with for when you're actually starting to use a library, when you're starting to use a code? You need an interpreter, a package manager, and environment manager. So what are the differences between those? An interpreter is basically something that would take your Python code or Ruby code and translate it into a machine understandable actions. So you basically, if you want to interact with Python, you go about and just pull Python executable from the Python website, download it, and start using it. Start writing code and executing it in the Python runtime or interpreter. Package Manager is what allows you to download or install the libraries. So if you want to leverage PyODBC or maybe Pandas, you rely on a package manager, a pip or a Conda, for example, to download those libraries. There are different repositories out there that host different libraries. So what you need to do is just pip install the name of the library, and it would install that library from those remote websites or repositories. Conda is another package manager. What is an environment manager? This is a question that I think we encountered a lot at our day job. So let's say that you have developed a project or an application that relies on a Python 2.7 and a set of libraries that work only on Python 2.7. Now, 2 years from now or a year from now, you want to leverage another Python interpreter like 3.6 or 3.7. What should you do? This is where Environment Manager comes into play. Environment Manager allows you to separate your projects based on, or separate your environment based on the project. So you can have an environment that has a Python 3.6 and Pandas or Python libraries that can work in 3.6, and then have another project that is based on a different interpreter like 3.7 or 2.7, and have the libraries that work there. So that it provides that logical isolation between the different projects. Okay, so we covered the code part. Any questions or maybe ideas? Okay.
So there's an enormous variety of open source software out there. It's just absolutely astounding. There also seems to be a lot of quality variation in terms of error handling, bugs, poor architecture. When you assess that incredible library of choices, is there any ratings of any of this that are worthwhile?
Well, I haven't seen any formal rating, but it's kind of a general rule of thumb. You can visit the library's Git repository and check how many issues are there, when was the last commit made, how many people have forked that library or started. So GitHub becomes kind of the tool of evaluation, but it's a quantitative measure. It's not really fixed in stone.
It's an indirect measure then.
Yes. Yeah.
Quick question. With libraries, especially like R and Python, where you can just pip install something or just load it from CRAN, are we worried about like malicious software injection in our corporate environments? Like it's a really big package to bring in software to like a big corporate environment that's normally very locked down.
Yeah, it's a valid concern. Sorry, yes. Yeah, sorry, yeah. So the question here was, if we're relying on open source libraries like in R and Python, how worried should we be from a malicious interactivity or a code that is being injected into that library that can harm the corporate environment? Is that the question?
Yeah, exactly.
Okay, so that's a valid concern for sure. But I think this where open source technologies are much more stronger compared to proprietary software. Proprietary software, you are limited with the resources of the providing company to provide any qualitative measure or any maybe measure that would indicate that the library has been either hacked or has been compromised in some level. Open source, because you're relying on a wider community, those type of issues are discovered quite faster than compared to the proprietary ones. So again, it becomes like a qualitative measure. Has there been any issues reported against those libraries? Has there been any security concerns reported against the libraries? There are security publications as well that highlights the the zero-day attacks or otherwise for each of the open source technologies. So you can definitely check those. There were actually recently there was a zero-day attack against one of few of the Rails framework libraries. So the publication came right away saying, upgrade right now, don't wait. It doesn't reveal what the issue is except after a few weeks. So you need to keep an eye on those, and once it is publicized, you can just update your code, and they provide you with mechanisms to do that as well. So interfaces. So this is the third part of the equation. So this is how the user interact with the code. We have browsers, which is kind of the modern day interface, and those typically interact with web-based applications. Mobile native, which are the applications on your phone, and then progressive web applications, which is a mixture of the two. So it provides some sort of a web interface that is you can use also in a disconnected way. So you can actually download an application that is in itself is just a browser interface or a browser wrapper that provides maybe a notification or a disconnected communication with the server. So for browser-based ones, browsers understand only three things: HTML, CSS, and JavaScript. So whatever you're writing that should be understood by the browser should be in one of those. HTML is the markup, which is the language that takes most of the page. CSS is just to provide some sort of a nice UI in terms of colors and organizations. And JavaScript is just for interactivity. So if the user clicks on that button, please you can code it so that it pops up a message or display a little bit of a modal view on top of the page or otherwise. This is the same page, by the way, the Raptors page. I don't think you can see it, but it's basically chock full of HTML and JavaScript. So I think that's it in terms of components, unless there are any questions here. We're going to move into processes. So this is more on the softer side of things. So how do you actually go about developing your solution or application? So I would like to talk about three things: the version control, agile methods, or the agility in nature, and code quality. So version control. So traditionally, you can develop your application or script and store it on your machine, and then have a copy, and then you can share that copy, and then it becomes copy final and copy final 1, and then another user does that. So there are better ways that came about a long time ago, actually. Those are called code repositories or source code control. So those allow you to share your code seamlessly with other users. So basically, you can develop your code and then commit and push that code remotely, and some other person would pull it on their machine, work on it, and then you can start collaborating between you. You can add a line of code, they can add a line of code, you can compare them, you can see what the differences are, so it becomes easier for collaboration. The most common out there now is Git. This is a source code control tool, and not to be confused with GitHub. So you can actually have Git within your organization without having GitHub. So Git would still allow you to share your code, commit it, and actually do all the cool things about differentiating your code, merging it, pulling it, and all of that. GitHub is some sort of a wrapper around it. It's actually a service provided by GitHub, now Microsoft, that allows you to actually share it with wider audience, or allows people to comment on your code, or have some sort of issue reporting mechanism against the code. And this is where most of the open source tools now are hosted. So this is just the key differentiator between Git and GitHub. BitBucket is another tool similar to GitHub. It's from Atlassian, big company from Australia, I believe. There is also GitLab, which is an open source equivalent of GitHub, but you can host it internally. And GitBucket is another also open source tool. So you can have your own internal application that allows people to share code across or comment on the code or actually issue pull requests and kind of evaluate the code without having to download it. So provides a bit of functions. So I just put this slide up there to talk about that line of separation in the M-tier environment, the interface code database, has nothing to do with your development environment. So your development environment comprises of your local machine or maybe a remote machine that communicates with a Git server. But when it's time to use the code or make it available for other, there are some deployment mechanism that takes the code from the Git server and pushes it to where it should reside on the code server. So your development branch shouldn't be, or development layer shouldn't be confused with your application layers. Part of the process is the Agile methods, and I'm a fan of Agile methods. It's basically a way of collaborating around code that makes a large sense nowadays. Traditionally, code has been written in a waterfall way, meaning that you have to define your requirements upfront. You have to define all your features upfront to the nth degree. You have to define your architecture to the nth degree before you even start writing a line of code. That's traditionally. This is called the waterfall method. It's still followed for some mission-critical applications like NASA applications or otherwise. But nowadays, the notion of developing software is more collaborative in nature. So it is people-focused. You get together in a cross-functional team. You have the SMEs, you have your subject matter experts, you have your data scientists, you have software engineer, your data engineers, all collaborating around software and having an understanding of the value that the Agile Manifesto provide gives a lot of people in those teams so much power. So those values are just go through them quickly here. Individuals and interactions over processes and tools. So it focuses on people, their changing needs, their understanding needs over strict processes and strict tools. Working software over comprehensive documentation. Instead of writing a 1,000-page document to capture requirements and features engineering, you can just rely on software, rely on your working software to capture those requirements. So basically you work in iterations, you understand a bit of requirements, what is needed for the next couple of weeks, you work on it, you deliver it, and this generates the next round of requirements and the next round of understanding from that cross-functional team. Customer collaboration over contract negotiation. When a customer usually uses the software, they come up with their own ideas of how to use it or what features need to be included next. So that becomes a platform of idea generation. And instead of you writing everything down in a contract, you can just agree that this project is going to take between 12 weeks to maybe 20 weeks, and then within those weeks we're going to develop that functional software. So it puts an emphasis on the collaboration part. Responding to changeover following a plan, that again plays in the same theme here. And maybe a note here that modern technologies, modern languages, modern tools actually adopt the notion of responding to a change. I remember lots of projects, I would be sitting alongside the customer, the client, asking me to add things to the working software, the production software, and I would be adding it. definitely following some sort of testing, but pushing that software right away into the production stream, meaning that I don't have to negotiate with a client. I don't have to follow a strict plan. It is more adaptive in nature. Another word about increment versus iterate, and I love this slide. I am not the author. I should reference the author name here. I'm sorry about that. But basically, it's a comparison between increment and iterate. Modern software development now follows the iteration plan. So you start with a vague idea of where you want to reach. Maybe you have an end goal in mind, but what you can see in the near future, it might be different from maybe 2 or 3 months from now. So you start with a vague idea, you start developing something, you start delivering something, and then once you show this to the client or make it available for user, you start generating more ideas and more understanding of where you want to be. And instead of building it on a block way or a block fashion, it's more of a painting that you iterate on. And there is definitely an overlap between the software engineering and software as an art. So find myself sometimes saying, well, I'm putting a finishing touches on something. Finishing touches meaning that it's almost there, but it's not yet there. So it's more of an art rather than a science aspect. Anyway, so now, does Agile mean cowboy? Certainly not. There are different ways that we can follow a plan and make it more rigid in terms of understanding of our progress, or whether we're falling behind or actually delivering meaningful solutions. So there are many methodologies out there that you can adopt. Scrum is one, Kanban is the other. Extreme programming was famous, I think, early 2000s. Pair programming is another. Pair programming is a very fun way of developing. Basically, you actually sitting alongside with another developer working on the same feature on the same machine. They have the keyboard, you have a keyboard, and then you start iterating on the feature. So you drive ideas from each other, you talk about the design of that feature together, and then once it's delivered, it's tested, and so on. You swap the driver and the passenger seat.
Two keyboards?
2 keyboards, 2 mouses, 2 brains. Code quality is the third part of the process part. So data integrity, peer reviews, and automated tests. So I'll let you read this part, but it's a fun comic. It basically talks about an attack against one of the websites. So basically here you can, if you're not careful enough, you can actually allow users to embed code in your forms, in your web forms, that can remove records from the database. So you have to be very careful of your user interactions. The rule of thumb here is not to trust the user. It's just make sure that the inputs that they are providing is very well sanitized. And that speaks to the power of the frameworks or the libraries. So when you leverage those libraries and frameworks, most likely you're also leveraging the knowledge of people who have developed those libraries. So they put their experience and their know-how on how to communicate with databases or how to sanitize user input in those libraries. And once you leverage them, you're actually gaining all of this information. So frameworks are very powerful in that sense. Peer reviews, and this is another fun comic. It's WTFs per second, how you're measuring actually the quality of your code. And I remember a story about Bill Gates here as well, basically going through peer reviews, but this is the only measure that they have used. And just what I would like to say is that peer reviews are important, especially for junior programmers or people who are coming from different practices. So you have to have that sort of trust communication of showing your code to others. It's nothing to be ashamed of. Code is most likely wrong until it is right. So lots of code is full of bugs out there. So there is nothing wrong with showing your code to other members, getting ideas from them, getting feedback from them, and reflecting that on your experience. Automated tests are also very important. So automated tests are basically it's the code that tests your code. And this is very important when you're dealing with non-compiled languages like Python or Ruby. So you have to write your main code that does your main functions, maybe pushing data to a database, pulling data from database, massaging the data, displaying it. But you also have to write the tests that test that code. And the reason is after a while, though the code base tend to, I wouldn't say rot, but tends to be forgotten. So once you develop something and leave it maybe for 3-4 months, it becomes a foreign entity to you. This is when you bring up the code and run your automated test to make sure that everything is in a good shape before you attempt even to make any modification to it. It is also very important in weakly typed languages like Ruby and Python as well. Weakly typed languages are the languages that you can assign anything to a variable. So I equal horse, or I equal car, or I equal 3. So you can actually overload that I in your execution with anything. So writing automated tests, make sure that your I actually is what you're expecting. And just a short word about automated tests. There are frameworks out there also that actually adopt the notion of automated tests. Rails is a very strong one. Django is another. It gives you the power of lots of testing libraries and tools that allows you to easily write your tests. Okay, so we're going to talk about tools, and I promise it's going to be a long one. But any questions so far?
Oh yeah, I got a question.
Yeah.
What kind of testing do you consider the most important? So if I have one aspect of testing that I want to implement, what integration testing, unit testing, what do you think is the best?
Usually start with unit testing because it is closer to the code. So unit tests, you're testing your models, you're testing your database interactions, you're testing it at a lower level. If you go higher up or go from the other side, like functional integration testing, then it's hard to capture the issue. Capturing the issue makes more sense when you're writing tests that is closer to the code. So unit tests, functional testing, then integration testing.
Do you have any recommendations for trying to get engineering-based teams, like maybe oil and gas professionals that aren't professional software developers, writing tests? Like in my environment, we do a lot of like prototyping and kind of notebook-based test development, and we find testing a really big challenge.
Yes, that's a very good question. I think part of the problem is the tools or the tool sets. So Jupyter Notebooks or Jupyter Labs does not actually encourage the writing of automated tests. However, if you're writing your projects outside of that, you kind of lack of the nice runtime environment that Jupyter Notebook brings. So it's kind of a trade-off. However, I think if you're starting to migrate away from notebooks and adopt maybe a more project-based approach to writing your scripts, I think it would give you some room to promote that notion of automated tests. Show and tell maybe other thing, like the risks of capturing user input as well might help. If you're providing some interactions in your notebooks or Shiny apps or whatever, you can embed JavaScript messages, alert messages, and it would show the risks of actually exposing that to the user. So people will get an understanding of how important to run automated tests, how to sanitize the inputs, and also all of that. Yeah, I don't have just silver bullet here, unfortunately. Okay, so tools sometimes matter. It's not always the case. So sometimes. DB clients. You should use the best tool that fits what you need. So DB clients are there to interact with the database. Shouldn't be using your. I would say you shouldn't be using your IDE to do that. You should be using a rich database client to explore the data, navigate through it, run SQL queries, find association, maybe try maybe designing the database through the database clients. There are other tools for that, but anyways, so database clients are there for that purpose. IDEs are there to develop your code. They are not there to run your server. They are not there to interact with your database. They are there to write the code. You can run your tests within IDEs, but I prefer running them outside of the IDEs as well. So you can treat IDE as kind of dummy, or not dummy, but maybe rich editors, not necessarily integrated development environments. That's my preference, at least. Cloud. So I put cloud there because, in my opinion, it's a tool. It's not a target. It shouldn't be a goal. It should be just there for being a tool. And we're going to address that a bit. So some of the database clients that you can leverage out there, DBeaver is the most common one. I think we did just discover that very recently, but it is a quite rich tool. It's Java-based, but that's nothing against it. SQuirrel is another open source one. DBeaver, by the way, has both a community version, which is open source, and there is another release. I think you can pay for it. The SQuirrel is totally free, totally open source, but the interface is a little clunky. You can actually use it. SQL Developer is another one from Oracle. It's not open source, but it is free as long as you use Oracle, as far as I remember, but which is quite expensive.
A little encouragement.
But it doesn't have everything even. Like it's somewhat limited. IDEs. This is a list of IDEs. My preference, I prefer JetBrains, but JetBrains is a paid. Actually, they have a plethora of IDEs. IDE to write your Ruby code, Python. They have a PyCharm community edition, which is free. But yeah, most of their products are paid. Runner-up is Visual Studio Code. I know Marc loves it.
It's the other way around.
Okay. Yeah, so I'm coming to the realization that it is a good editor. PyCharm is from JetBrains, so that's another one, community edition. Jupyter Labs it's decent. It's not bad. Sometimes I have to use it, but it's not all the time. Cloud. This is, in my opinion, what cloud is providing, is elasticity. Maybe flexibility, but elasticity is more. So you leverage cloud because you need more resources. You want to expand and contract. You need to use more machines. You need to use a bigger database than a smaller database than another database. So it gives you that sort of faster turnaround, kind of experimentation environment. You can definitely use it in production environment, but cloud also comes with baggage. It comes with complexity. It's not straightforward. It's not as people think. With every abstraction layer, you're adding another layer of complexity. So if you want to communicate with the database and client, you need to make sure that the channels are open. You need to make sure that firewalls are open. You need to make sure that there is actually a DevOps wrapper around that environment. Like, there are lots of things that you have to take into consideration before you leverage cloud in a full sense. However, I'll come back to that. Cloud is elasticity. And there are different service level for cloud. So IaaS, or infrastructure as a service, is basically you're buying a machine that is hosted somewhere else. It's the same as this machine, it's the same as the machine sitting on your desk, but it is actually sitting in AWS or Azure or somewhere else. So you're responsible for all the patches, you're responsible for installations, all installations of the packages, applying security patches, installing databases, installing your IDEs, all of that within that IaaS offering, infrastructure as a service. You're basically buying metal or compute and memory, that's about it, and storage. PaaS is the second level up. PaaS is an IaaS, or an infrastructure or machine, plus an added service level that would take into account all security patches, all installations, all the server updates, all communication between the server and the database. So this is kind of the second level up. My favorite there is a service called Heroku, which got bought by Salesforce many years ago. But it provides that environment that allows you to push your code to their servers, and that codes become operational right away. You don't have to worry about installing anything on their machines. You don't have to worry about creating a database, migrating a database. It's all taken care of just through a git push, just pushing your code to their servers. SaaS is yet another layer of offering, which is software as a service. We all use that, whether it's LinkedIn or GitHub or any of your social media tools. It's all software as a service. You're buying features, you're buying a product as it is. You have very little opinion about how this product is developed, directed, what is the roadmap, what features you're getting when. So be cautious of that. Just if a company is offering a SaaS, take it on face value. This is the offer that we're getting today. Whether the company is going to be remaining in business 5 years from now, who knows? Now, X as a service. What is X? It's everything as a service. Now everything is offered as a service. You can buy authentication as a service. You can actually store your user information on someone else's server, and then in your application, you're reaching out to that service, pulling the user information, using it in your application. So everything now is becoming a service. There are also algorithms as a service. There are functions as a service. So you can actually leverage functions that for object detection, which is the most famous use case from Amazon recognition, Azure, Google. You can just pass an image to that service, and that service would detect what objects are included, and you can pull that information, store it in your application, push it to the user, display to the user. You can do whatever. So everything is now becoming as a service. Now, with that in mind, that again provides another level of abstraction that you need to take into account when designing your application. That's another level of complexity. Yes, you're getting the best of breed, but you're adding complexity to your solution. I think we are now at a stage where applications are not hosted anywhere. Yes, I understand of the notion of serverless application. It's not truly serverless. But your application can be comprised of an authentication service from Amazon, object detection service from Google, maybe an OCR version from Microsoft. And what your role is just to provide the communication layer between all of these services. So who knows what the future holds, but I'm totally excited about it. I think that's it, unless there are any questions. Marc, I think, will come around to repeat the questions.
Sorry, if software is eating the world, it feels like we just need a dictionary tonight. So just to let you know, we're recording this so that You may be able to access it a little bit later. We'll see how it works. We'll try to figure that out in a couple weeks. So as a result, when you ask your question, I'm just going to basically reiterate it so that the mic picks it up so that we can actually have that as part of the recording. So sorry, someone over here.
Is pgadmin that comes with Postgres, is that also a database client? It's the same thing as those other ones you listed kind of thing, or?
Do you need to repeat the question?
He's close enough.
Okay. It is a client. I think the latest iteration is a web-based application.
Yeah.
And it sucks. It
Yeah.
is terrible.
Oh, okay.
So.
It's the only one I've ever used, so.
Oh, really? Okay.
We're brand new to it, so.
Okay. So I would recommend using DBeaver.
Okay.
You can use SQuirrel as well, but yeah, it's not the best really. pgadmin.
Yeah. It just came with it, so.
Yeah, it comes out of the box, but it's not the best.
Okay, thank you.
So when you're starting off, maybe you're onboarding a new business or something, you're building tech for them, and you're starting off with their database. Is there ways to structure your database so that you know you're going to be handling big data later? Is there little hints or things that you should develop in your relational database before you, so that you can make the easy transition into, say, Spark or something? Is there, or is it just like a strict, you gotta just redo it all?
Okay, so it is more about big data, right?
Right.
And you currently have a volume of data to communicate with. Or
Say you don't have any data right away, but you know you will.
I would stay away from premature design. You have to design based on your inputs now and what you know now. There is nothing wrong of iterating on top of your solution as long as you have the pipes connected. So you can start with a relational database, have your ETL script pulling the data from some source, pushing it to the database, providing some sort of an analytic on the downside, on the user side, and see what they come up with. Now, once your data grows, or once you start sourcing your new data, then you iterate on the data extraction layer or ETL layer, and push the data maybe to another repository. But you have somewhere you can start from, instead of designing everything from scratch from day
It's
one.
the iteration process.
Yeah, iteration process. Yeah. Again, those are kind of opinionated, I guess, ideas. You take it, or just maybe you find something else.
Right.
There are two questions.
Kind of related on top of that, do you have any recommendations or cautions against developing front end first and prototyping and iterating based on user needs versus developing back end first?
So
I'll just reiterate that question. So the question was, do you have any cautions or considerations in developing the front end before developing the back end?
Yeah, more or less.
yeah, I don't know if there is a better way. There is a way of actually isolating the two, developing a back end versus a front end. I think the notion of developing a database or records as a back end, I think, comes from the analytical side, but eventually that data needs to be used somewhere. And if the intention here is to embed it within a business workflow, you need to provide the design and the implementation of the front end as well. Front end doesn't necessarily mean a UI that a user can go to. Maybe it's a service layer that you need to present on top of your data so that it can get consumed by another service or another application. So you need to think of those holistically, but start small. Start with maybe a simple UI, a simple backend database, interaction in the middle, some analytical scripts in the middle, and then see what that leads to.
Thank you. Thank you very much for your presentation. My question has to do with the fact that in general the tech industry, the tech sector is always seem to play catch up with their needs in terms of developers, so to speak, or software engineers, and here's where all the terms mix up, right? You got developer, data scientist, data engineer, software engineer. How do you see the oil and gas industry, Calgary in particular, catching up with this? Is there not enough supply? What's the demand like for proper software engineers? I've worked in jobs where I've told, no, I'm not a software engineer, I'm a developer. I mean, I can hack everything, but I'm not a proper software engineer. Because maybe I don't have the credentials. How do you see the oil and gas industry catching up? Are they already starting to understand the difference between data scientists, data engineer, and a developer in general? Is that happening?
I think everyone in this room has an opinion about this, this topic. I can start, and Marc and Tim can also jump in. I think when it comes to knowledge industry in general, technology, there is a lack of understanding. And I think we have seen that in the wave of outsourcing the jobs from Calgary. That outsourcing wave, I think, was just, I think, fashion at one time. Everyone was outsourcing, so we should be outsourcing. It didn't really look internally of what are the problems we're trying to solve, what type of industry we should be having, what type of resources, or sorry, I hate that word, talent we should be actually building. And it just looked at one thing. Currently, I think it's a ripple effect of that lack of understanding, is that there's not enough in the decision-making chain of understanding of the technology in order to make good decisions about sourcing the people needed for those type of activities. Data science in general also is kind of a new thing. I see the lines getting blurrier by the day of what is a software engineer versus a data scientist versus a data engineer. It's kind of mix and match. So I think the next few years will bring a lot of cool things in general. Calgary is also kind of a fast follower. I don't know, I was speaking to someone before the session here. So the US dictates a lot of that. So we'll see how it goes over there before we're seeing Marc, I don't know, Tim.
My only comment is that I'm pretty sure that HR does not understand what these things are. There's no question. I've literally read job postings that are pretty much an itemized list of what Tamer showed over the last hour. They want a DBA, they want a software developer, they want a geoscientist, they want everything under the sun in one shot. It's a work in progress, obviously.
10 years experience in TensorFlow.
Yeah, exactly, right?
No wonder they don't get anybody.
So if I'm creating a service which is taking a live data stream and doing analysis, which language would you recommend and why?
I'll just repeat. So if I would like to create a streaming service,
Like if I'm creating an app or whatever,
creating an app
which
using,
is taking a live data stream coming in, so which language would you recommend?
yeah, so if you're trying to create an app with a live data
Yeah.
stream, what language would you use?
Yeah. I don't think it's going to be a matter of language as much as of what tool sets you should be using. So, and again, depending what your definition of live streams. So if it's real-time data from
Yeah.
an IoT device, for
Yeah.
example,
Something like that.
then you need to look at a PubSub toolset, publish-subscribe toolset, some sort of gateways that basically it takes in the feeds from those feeds, but also there is a redundancy mechanism that allows you to not to lose the data. And then this service will be pushing the data elsewhere for more permanent storage. So you need that intermediate layer to consume the stream and then push it somewhere. There are tools out there, I believe it's called Kibana. Sorry, I totally forgot the name. Yeah, that's one. There are open source ones as well. Yeah, I can look it up for you. there are tools out there that does that.
Question on Agile methodology. So I think there's some who still don't believe in it, who might think it's for lazy people who can't think of what they want nor write it down. So how would you counter that argument? Would you counter that argument? And might there be conditions that you've seen at work and others not? I'd like to hear your views on that.
Yeah, I mean, I think the main challenge here, actually there are two challenges. One is a budget-based challenge, is how you can assign money to that project when you don't know how long it's going to take. The second is the process challenge, how you can stitch the agile process within the bigger organizational process in terms of reporting or otherwise. So I'll talk about the second one, it's the easier one. I think you need to adopt some sort of an agile framework. You cannot just go say I'm gonna develop my project using agile. That's my opinion. You have to adopt either Scrum, XP, and Kibana, or some sort of a measure that will give you some sort of a feedback of how good your process is. Because that would form the reporting structure that we can then feed back into the bigger organization. Now, in terms of budget, I don't have really a good answer for that. I think it's going to remain a challenge unless the budgetary framework will actually adopt or understands the agile process. Yeah, it's going to be a challenge.
Part is getting the PMO to think that.
Yes. Yeah, how can you assign a budget for this project when you don't know when it's going to end? Or yeah. Timelines is the challenging one. Time boxing definitely helps a bit, but it's not in terms of budgeting for long term. Maybe the budget cycle needs to be shortened down a bit instead of a yearly budget, or maybe it can be a 3 to 6 months budget. That makes it more adaptable.
I have a question quite related to this question, and I was going to ask you, how do you work with a client? I'm working with a very large company right now, and we're like, okay, we want to do agile development, agile project management, and they're like, yes, sounds good, let's do it. It's a catchphrase, right?
Yes.
But then as I'm working with them, I'm realizing that they actually have no idea what it means, and they keep falling back to waterfall.
Okay.
And so I have this challenge where, they say they want to do agile, but their lack of understanding of that is just making them fall into and their business processes are just not geared to that. So yeah, that's exactly my issue right now. They're like, okay, give us a budget. I'm like, well, a budget for what? Like a budget for phase 1 or?
Yeah.
So I don't know if you have any advice.
I'll just quickly repeat that. So the general idea of the question is, how do you promote and use Agile beyond its superficial or buzzword aspects where you actually do an Agile method versus waterfall?
So you mentioned that Agile is a catchphrase. I lived through times when it was a punchline. So people were just so married to the waterfall process, and Agile became just a joke. But I think now it's starting to catch up. I would say that you have to adopt a methodology. You shouldn't be adopting just going in, I'm Agile, and then this is what we're going to do, cowboy. We're just going through one cycle of iteration, deliver something, find what's next. You have to adopt a Scrum, XP, some sort of an Agile methodology to allow to at least give you some reporting mechanism that would show the management or the client how you're improving through time. I understand that Agile is also kind of flexible in the sense of nobody's implementing Agile methodologies to the nth degree, but try to, as much as you can, to comply with Scrum is providing or XP is providing. That helps a bit. I think also it needs a bit of education. So you have to, I guess, educate the client of how things would work. What I found not bad is basically breaking down your solution into iteration and having some confidence of how much time and effort you're going to spend within each iteration. So first few iterations, I think you are going to be the highest confidence, and as you move along, the confidence would be reduced, I guess. But showing the client that makes them on board with the process. It's some sort of assurance eventually. I don't know if that answers your question, but just a few ideas.
So I'm a petroleum engineer that's transitioning or has transitioned into tech, which is great. And I'm just about to graduate from a full stack developer program, a 6-month program. So, but what I'm finding is that a lot of there's this gap between, everybody's worried about oil and gas and there not being enough tech people in it, right? Mm-hmm. But a lot of the roles out there they're looking for 10-year people. It's the classic problem, right?
Yeah.
10 or 15-year developers. And I always think, well, I'm bringing all this domain experience, right, from working in oil and gas for years and understand the problems and all that. But that gets a lot of lip service, and there's still this gap, like you say, from HR saying we need all these technologies. What do you recommend? What's a great way to wedge? What's a way for a person to wedge themselves in there, and as opposed to starting as a junior developer? I don't know.
So yeah, it's the cookie cutter roles. You need to fit within that box in order for you to have some value in the organization, which is I totally disagree with. Ideas is that show your experience, develop your product that captures both your tech experience as well as your business or domain knowledge experience, and show that to the world. Don't have it sitting on a code repository somewhere. Have it actually functional. Have it, people can go to this website and interact with my product, and that does X and Y. That helps quite a lot. Not only from a Calgary-based perspective, but now the market is bigger than that, so it helps a lot. I tend to think now that products are actually the new business cards. You have to have a product under your belt to start showing it to different clients, different potential hires, potential event, whoever, the world. I think this is the new trend now.
Okay, that's great. Thank you.
No problem.
Just kind of to comment on his comment. Some of the startups in the city might be a good avenue for you to get some experience where they can really value that experience, especially if they're targeting the energy space.
Right. Okay, thank you.
Also to take on to that, do you have any suggestions with the instances where maybe you've only worked 1 or 2 places, you can't show the work that you've done at the company that's preferred or something?
Yeah. So that's always a challenge, the code hidden behind firewalls. It's okay. I mean, there is a better understanding now that sometimes you're developing for clients and this code is owned by the client, but I think you still have to have something under your name. So have your GitHub repository, add maybe a few snippets of code here and there. You don't have to have a full functional product, although it helps, but as you're getting there, just have something for everyone to see. You can also leverage things that are sanitized in nature or non-proprietary, like a library that you have used, that you added a modification to. That's usually falls under the copyright of the library owner, so maybe that also helps. Maybe even Stack Overflow, QA answers of your own to complex technical questions, those help.
What's the best way to estimate or price a piece of software or a solution, a digital solution?
From which side? From a client side or from the owner side?
From the person building it or offering the solution.
Yeah.
So do you, obviously there's hourly, your time, complexity and stuff.
Yeah.
But would you ever value a piece of software on the value it adds to the business?
Absolutely. So the question is how to value this, how to put a price tag on a piece of software that you develop. You should price your product on a value that is providing to the client. So not the time and material, not the libraries that you're adding, nothing else, just the value that it is providing. So, and make sure that you're positioning it well, and you can actually iterate on that. So you can position it initially at a level. It should be, from a client perspective, it should be not too cheap and not too expensive. Somewhere in the middle that it is saving them time, and it's hard for them to fork the price, but again they have to pay for it.
Would you ever show them it in say stage, like this is a stage, this is stage, this is stage, and like have them build on top?
Yeah, well, usually nowadays it's the multi-tier pricing model where you have possibly a freemium layer where it's free with limited set of functionality, but you can add on top of that. So a personal plan is X, maybe a community plan or a bigger plan like 2X, and then enterprise plan which has the price tag of call me. So.
Would you share that value like with a warranty, or you share on the savings? Would you put contingency on that? If they save you this many dollars, you give me 10%. Or is that too aggressive as a pricing?
Sorry, if it saves them money.
Would you say price your product on value?
On value, yes.
Okay. Would you say something like, I'll do it for 50% of your savings in this business challenge, whatever?
Remember, it's yeah.
Sharing the upside or the downside on the pricing on the solution that you're offering.
Yeah. So basically, what is the price tag you should be putting on a product you developed? Should it be based on a value or based on the saving that it is providing them, and whether you show it or not?
Whether you share on that.
I think you shouldn't be sharing it. You should be just putting a price tag, because it's a product-based model, it's not a service-based model. Unless your product includes a service component, meaning that you're going to go to the client, maybe, helping them maybe cleaning the database or extracting records from the database and pushing it to your product, that part of the process should be independent of how you're pricing the product. The pricing should be just, this is X, take it or leave it. Excuse me. For enterprise client, there is the negotiation aspect as well. So, but for smaller size businesses, it should be just the price tag on the product. If you're a B2B product, the process is quite intensive. So it requires a lot of hand-holding in terms of how you're selling the product to the enterprise client. So you should take that into account and make sure you're pricing the product at 3x of what the value is, because there would be negotiation.
There's a lady named Kim Orleski. So I don't know if any of you have met her. She goes into sales strategy and how to build pricing models and everything else. If you can ever get to her when she doesn't charge for a meetup and she gives away some of her pricing strategies, she has some pretty interesting concepts around that, right, from a sales and marketing standpoint.
That's Kim Orleski? Okay, great.
And she's on LinkedIn on one. Perfect. And Facebook.
Are there any products you recommend for dashboarding in particular?
Dashboarding? Are there any products for dashboarding? Yeah, there are lots of tools out there. I would say don't develop a dashboard. Sometimes it's overwhelming, and especially if it requires a lot of data is based on one dashboard. For example, it becomes of some sort of an IDES or a tiring thing that users should be looking at every day. If you are able to integrate your product or your solution into some other application, I think that would be the optimum. But going back to the question, there are visualizations tool out there. If you're looking for open source ones, I don't know, Mark, have we used, like, depending on the language as well.
It highly depend on the language, yeah.
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 There's a huge variety of JavaScript libraries for dashboards that are open source.
That's true, yeah. So, yeah, if you're familiar with JavaScript, then D3 is one of the libraries. And there are abstraction libraries on top of D3, so you can leverage those. Lots of charting capabilities, but again, depends on the language. Whether you're generating the dashboard on the server side, on the client side, we can discuss this if you like. Later after that.
Any other questions? Oh.
I have a question. We developed some software using Python and TensorFlow, but the client wants to packaging. So is that ethical to packaging the open source software, or?
There is nothing wrong about packaging software, open source software. Just check the license. Some licenses allows you to commercially distribute and repackage software. There are companies out there now leveraging products from other big companies, big initiatives. I think the most recent one is Amazon having some problems with Apache packages because they are actually selling it as their own. Yes, they might be doing some stuff, but the underlying layer is open source, but they are packaging it as them. So there are few things going on in the industry, but there's nothing wrong with packaging the open source based solution. Sorry? Oh, okay, yeah, so Linux, yeah, absolutely. I believe Red Hat as well. Yeah, different. Yeah. Yeah.
Can you break down of all like the sectors of infrastructure code and database, things like that? Where does something like Docker fit in?
Docker is a containerization mechanism. So I would take it as part of the deployment part of your life cycle. So basically you develop something on your local machine or remote machine, but in order to deploy it on a different infrastructure, you need now to package it. So one option is use a PaaS provider, platform as a service, IaaS, or a container environment. Basically, you package it as a container and you deploy it somewhere so it becomes available for others. Okay.
Very well, thank you very much.
Thank you so much. Yeah.
And thanks to Tamer. That was a great discussion. So I just wanted to finish up on one thing, if I could do this. Most directly to your question here up front in the middle. We were talking about full stack software development. When I'm more in the data analytics space, and when I read these requirements of what people expect, I mean, it does seem a little ridiculous. So I kind of push this out and I say, okay, look at the middle part. That's the important part, the business mindset, and the soft skills part. We have many, many years of experience there, okay? That's really important. And yeah, the statistics stuff matters, believe me, and so does the software engineering. But that's a very fast-moving boat, and you just have to jump on and go for the ride, right? But the key part, we have a lot of that already. And so not everybody has 20 years of TensorFlow and everything else under the sun, right? I mean, there's a lot of this is just good analytical mind. That's what matters. But I mean, it's a bit of a tough sell sometimes.